Today's video is on graphing motion. Here we have some examples of motion graphs, and these lines on the graph tell you different things about the motion of an object. And throughout this video you will learn how to interpret motion graphs such as this. But first, let's review our previous video concepts, and that is on motion. So I want you to pause your video and in your notes answer these questions, and if you need to go back and look at your notes from previous videos, that's quite all right. So the questions you're going to be answering today are: number 1, what is the difference between distance and displacement? Number 2, can an object have negative distance? Number 3, what is the difference between speed, velocity, and acceleration? And number 4, where are the points of acceleration in a 400-meter race, which is one lap around a track? I want to know where during that race would the runner be accelerating. So go ahead and push pause and answer those questions now. Now that you've had a few minutes to answer those questions, let's take a look at the answers. Number 1, what is the difference between distance and displacement? Well, distance is simply how far something has traveled. And then displacement is how far it has traveled away from the reference point. Number 2, can an object have negative distance? That answer is no. Distance is always going to be increasing. It's never going to go down. Remember the example of the car? Every time you get in the car, you're adding mileage to the car. It doesn't matter if you're traveling away from where you started or back towards where you started from. Your mileage, your distance will always increase. Displacement, however, can be negative. When you're moving away from your reference point, that is positive motion. When you're moving back towards your reference point, that's negative motion. Number 3, what is the difference between speed, velocity, and acceleration? Well, speed simply describes how fast an object is moving. It's either moving fast, it's moving slow, or it's not moving at all. Velocity describes two things: how fast the object's going, or its speed, but also the direction, like forward or backward. Acceleration describes a change in velocity. And so if there's a change in speed, speeding up or slowing down, or if there's a change in direction, then acceleration has occurred. So in our 400-meter race, acceleration will occur at the starting line when the runner is speeding up. During the race, at periodic times throughout the race, the runner might speed up, slow down a little bit, so acceleration will be occurring there. At the finish line, when the runner passes the finish line and begins to slow down to a stop, that's also acceleration occurring. And anytime the runner is going around one of the curves, their direction is changing, so acceleration is also occurring on the turns. So let's talk about motion graphs. There are 3 different types of motion graphs that you're going to need to be able to recognize. The first one is a distance versus time graph. Notice that the distance is labeled here on the y-axis and time is measured on the x-axis. The second graph is a position versus time graph. So we just changed the label on the y-axis. We change it from distance to position. So now we have a position versus time graph. And the third one is a speed versus time graph. So once again, we just changed the label over here on the y-axis, and it's now speed over time. On these graphs, you're going to have lines, and the lines, the slope of the line is going to describe the motion of the object. For example, if the slope is very steep, so steep would be like this, a very steeply sloped line. That is going to tell you that the object is moving very fast. If the slope is a little more shallow, more gentle like that, then that's going to describe motion that is slow. And then we also have positive and negative motion. If your line is sloped upward, then that represents positive motion. And if the line is sloped downward, then that represents negative motion. So let's begin with the distance versus time graph. A distance versus time graph is known as a speed graph. because speed, the two factors that determine how fast something is going, is the distance it travels and the time it takes to get there. So the first thing you need to do is look at your axes. If it's a distance over time graph, then you know it's a speed graph. And when we talk about speed, we're only talking about how fast something's going. So the only thing you can interpret about the motion of an object on a speed graph is its speed. So if the slope of the line is gentle, then that's telling you that the speed of the object is pretty slow. If the slope of the line is very steep, then that's telling you that the motion of the object is really fast. If the line is flat, that is simply saying that over time, 2 seconds, 4, 6, 8, the distance is not changing, and therefore the object must not be moving, so it is at rest. Remember that on a distance versus time graph, since distance cannot be negative, these lines will always go up. You will never have a slope that is going downward on a speed graph because you cannot have negative distance. The next type of graph is a position versus time graph. So we've simply changed the y-axis here to position over time. A position over time graph describes velocity. And remember, velocity tells you not only how fast something's going, but also the direction that it's traveling in. Oh, wrong way. There we go. So this line right here has a very shallow slope. So it's telling you that the object is moving slow. It's also angled upward. That's positive forward motion. So this object right here is traveling slow away from the reference point or forward. Here is another line segment. It's also moving forward, up, away from the reference point. Positive motion. But the slope is a little steeper, so we know that the object's moving a little bit faster. So this one's moving fast and forward or away from the reference point. Here, the object that was moving slowly away from the reference point simply turned around and started going back towards the reference point, going back towards the position that they started at. And they started going backward at a pretty slow pace because the line is the slope of the line is relatively shallow. And here, on this line segment, remember this one was the object going really fast and forward away from the reference point. Then this object also turned around and went back towards the reference point. But this time they're going back towards the reference point pretty fast because the slope of the line is pretty steep. On a position versus time graph, we can also see an object not moving with that flat line like this. Over time, the object's position is not changing. It's not going any further away from the reference point. It's not going closer to the reference point. It's simply staying at the same position over time, so it's not moving. On this type of graph, on a velocity graph, your line can go forward and backward. So you can have positive motion or negative motion. So your line can go up, your line can go down, because now we're talking about position. And you can have positive position if you're moving forward, or negative position if you're moving backward towards the reference point. Our third type of graph is a speed versus time graph. So we've changed again the y-axis and it is now speed over time. So now we're talking about how the speed changes over time. And if there's a change in speed or velocity, then we call that acceleration. So a speed versus time graph is an acceleration graph. It shows you whether the object is getting faster or slower. So here we have a line going up. That's showing you that over time, the speed is increasing. It's going 2 meters per second, and then it's going 4 meters per second, and then it's going 6 meters per second, and then it's going 8 meters per second. So the speed is getting faster and faster and faster. So a line slope that's going up on an acceleration graph is telling you that the object is increasing its speed. If the line begins to go down on an acceleration graph, that's telling you that over time, your speed is decreasing. So from 6 seconds to 12 seconds, the speed goes from about 8 meters per second all the way down to 0 meters per second. So it slowed down. A straight line like this on an acceleration graph means constant speed. Unlike the other two graphs where a straight line represents no motion, here this is telling me that the speed is remaining constant at 6 meters per second. Over time, the speed is not changing. It's still 6 meters per second. It's still 6 meters per second. So the object is traveling at a constant speed. You can, though, see an object at rest on an acceleration graph. If you look at a line down here, this line is a straight line, meaning that it's traveling at a constant speed, but this time the speed is at zero speed. So the object is not moving. If it's not going a speed, if it's not going anywhere, if it's staying at 0 meters per second, then the object must be at rest. So on an acceleration graph, we can also have a line that's going up, positive motion, that's speeding up, or down, negative motion, which is slowing down, negative acceleration or deceleration. Interpreting graphs, guys, is going to be pretty hard. We're going to do lots and lots of practice. Make sure you bring questions in to me tomorrow, and I will see you then. I'm out.